Hi, it's Ms. Parrott, and this video is about how to determine the limiting reactant. So, a limiting reactant is simply a reactant in a chemical reaction that limits the amount of product that can be formed. Here's a simple example. So, if it takes 1 cup of batter and 1 cupcake cup to make a cupcake, let's say you had 20 cups of batter but only 16 cupcake cups. You couldn't make 20 cupcakes. You could only make 16 cupcakes, and you would have 4 cups of batter left over. Because the amount of cupcake cups limits the amount of cupcakes that can be formed, we would call that the limiting reactant. There are a few easy steps to determine which reactant is in fact the limiting reactant. So for every reactant you have, you're going to go through this process. First of all, using stoichiometry that we learned before, you're going to convert grams of reactant to moles of reactant. Then, using the ratio from our balanced equation, the coefficients, you're going to compare moles of reactant to moles of product. Then you're going to convert moles of product into grams of product. Then you're going to compare the grams of product from each of the 2 reactants, and whichever reactant produces the least amount of product is the limiting reactant. We're going to go through a simple example with cupcakes and then a more complicated example with a chemical equation. Okay, so going to our cupcakes, so we're going to set it up in our train track action. So if we're given 20 cups of batter, and then our ratio of batter to cupcakes, right, of reactant to product is 1:1, then we can cross out our units and know that if we have 20 cups of batter, we can make 20 cupcakes, assuming that there are plenty of cupcake cups. Now, on the other hand, let's say we only have 16 cupcake cups and unlimited batter. This is what we're given, and then, just like our instructions told us, we are going to use the ratio from our balanced equation. So there is 1 cupcake cup for every 1 cupcake. And then I'm going to cross out my units, multiply across. So with 16 cupcake cups and unlimited batter, I can make 16 cupcakes. Fantastic. Then my instructions tell me, B, compare grams of product. Whichever reactant produces the least product is the limiting reactant. And since 16 is less than 20, then the reactant that had 16, the number of cups, so our limiting reactant is cupcake cups. All right, now let's get more technical. In this example, we're combining zinc and iodine gas to make zinc iodide. That equation is already balanced. If it weren't, you would need to first balance it, of course. Here's the question. You have 1 gram of iodine gas and 0.5 grams of zinc. Determine, so we're determining 2 things, what mass of zinc you can make and the identity of the limiting reactant. So just a quick reminder, I'm going to show you one more time. For each of those, we're going to convert grams to moles, then moles of reactant to moles of product, and then moles to grams of product. Then we're going to compare. All right. So I've gone ahead and set up our train track. So since I know those are the steps, I can go ahead and see I've got the given mass, and I know I want to go to moles, so I'm going to have to use the molar mass. Then I'm going to use that ratio from my balanced equation. So so moles of reactant to moles of product. Since I want to get to grams of product, I'm going to use molar mass of the product as well. And that's going to give me my final mass of zinc iodide, which is what I want to do, right? Determine what mass of zinc iodide I can make. All right, so I'm going to go ahead and plug these in. I'm given 0.5 grams of zinc. I want to convert that to moles, so I'm going to use the molar mass. When I use the periodic table to get that, it's 65.4 grams of zinc in 1 mole of zinc. Now, I'm going to look up at my equation here, and for every mole of zinc, there's 1 mole of zinc iodide. So 1 and 1. Then I'm going to use the molar mass to convert moles of zinc iodide to grams. So again, using my periodic table, I have 1 zinc and 2 iodines. I'm going to combine that together to get 319.2 grams of zinc iodide. When I multiply all of this across and then divide by all of this, I end up with 244 grams of zinc iodide. So now, we've done it for the first one. Now we need to do it for iodine gas. All right, I'm going to work through this one a lot more quickly. Okay, I'm given that we have 1.00 grams of iodine gas. The molar mass of that, 253.8 grams of iodine in every 1 mole of iodine. All right, and then I'm going to use the ratio. Now we have 1 to 1 again. So for every 1 mole of iodine, we have 1 mole of zinc iodide. And now I'm converting moles to grams of zinc iodide. So for every 1 mole of zinc iodide, that mass is also 319.2, right? Same as before, grams of zinc iodide. When I multiply all of this top across and divide by this bottom, I get 126 grams of zinc iodide. Okay, so that is all of A, right? So for each reactant, we did all the stoichiometry to get grams of product for both of those. Now we need to compare the grams. So with 1 gram of iodine, you can get 126, which is less than 244. So 126 is less than 244. So given these 2 ingredients, the maximum amount of zinc iodide you could make is 126. Right? In the same way that in our cupcakes, the most we could possibly make was 16. So that means our limiting reactant is iodine. Hooray! So that's my example. I hope that helped you. You should find some other examples and try and work them yourself.